Let's discuss question 4. So you have a real valued sequence xn and limit n tends to infinity, n times xn. This sequence tends to 0. So you have to find all possible real values of t such that limit n tends to infinity, xn log n to the power t will also go to 0. So let's see how we can solve this. So the idea is simple, that is, first of all, you just multiply with n and divide with n. So since you have limit n tending to infinity, n xn is equal to 0. So, and since you have to work with limit n tends to infinity, xn log n whole to the power t, so it's better to multiply with n and divide with n. And now this part tends to 0. And so if we can show that the other part also tends to 0, then we'll be done. Now our goal is to show or find out those t's for which log n to the power t by n, this limit goes to 0. Now you can do this using L'Hopital's rule, but the fun of the problem ends there, and you don't get to know how the actual sequence is behaving. So for that we need to do some approximation. So I'll show you by some approximation and we'll push the limit to 0. Now I claim that for a greater than 0 and for all x greater than equals to 1, we have log x whole to the power a by x is lesser than equals to a to the power a by e to the power a. So let's see why that happens. D by dx log x whole to the power a by x is equal to a log x whole to the power a minus 1 by x squared minus log x whole to the power a by x squared, and that is equal to log x whole to the power a minus 1 by x squared times a minus log x. So at x equals to 1, as you can see, my claim easily satisfies, and also at x equals to e to the power a, the equality holds. Now this derivative is greater than 0 in the interval 1 comma e to the power a, as you can see here. So, and also it is lesser than 0 in the interval e to the power a to infinity because of this part. So if we see the behavior of our function, so that is at x equals to e to the power a, it takes the maximum value. So it increases and takes the maximum value, and then again it decreases. And so its maximum value is at e to the power a. And so our claim is satisfied. Now let's apply our claim. So let's take t to be any real number, and we choose a to be greater than maximum of t comma 0. Then as you can see, for all n strictly greater than 1, what we have is log of n to the power t by n. So this is strictly greater than 0, which is equal to, so let's manipulate this a little bit. So log n whole to the power a over n times 1 over log n whole to the power a minus t, and which is again lesser than equals to. So now I am again using my claim here, and so this is lesser than equals to a to the power a e to the power a log n whole to the power a minus t. And now we can say that this part tends to 0 as n tends to infinity. And so we can say that xn log n whole to the power t, which is equals to n times xn log n whole to the power t over n, tends to 0, because this is tending to 0 as well as this part is also tending towards 0 for all t in R. So this is our answer, and we are done with problem 4.